Okay, welcome to another lesson, falling bodies. So, falling bodies in physics, we're simply talking about some of the facts or things that do happen when a body falls. In other words, what happens to your U? What happens to the V, final velocity? What happens to the gravity? So that is what we're looking at. Now, according to a scientist called Galileo, if a stone of 50 kg is released from a height of 20 meters and another stone of 20 kg is released from the same height of 20 meters. Now, this is a teaser. Which one do you think is going to get to the ground level first? Let's assume this is the ground level. Which is going to get to the ground level first? I know many of you will guess wrong. Now, both of them is going to get to the ground level at the same time. So they will get to the ground level at the same what? Time. So it doesn't matter the mass of a body when it is falling. What matters most is, does that body have resistance to air? So that does not mean that if you have a body, for example, you're releasing a stone, and you're releasing a wool or a cotton wool from the same height of 100 or 20 meters. Will you then say that both of them will get to the bottom first? Will you say that? No. On a nonce, based on what Galileo taught us, is that the mass does not matter, but there is a twist to that, provided that the object has what? Air resistance. We all know that a cotton wool, this is a cotton wool, does not have air resistance. So as a result of that, the cotton wool is going to, be blown off by air, and the stone will get down before the cotton wool. Now, if an object is not resistant to air, then this will not hold. But if the object is resistant to air, it does not matter the mass of the body, both objects will get to the ground at the same time, provided that they are falling from the same height. Just as I said before now, what happens to these three parameters when a body is falling or when a body is being thrown upward? So let's look at when a body is falling down. So I'm just going to give a direction this way. Now, when a body is falling down, it means that the initial velocity is going to be 0. The final velocity can be computed or can be calculated as the case may be, or may be given, can be computed or calculated or even given. That means it can be determined. Then the acceleration due to gravity, which is g, is going to be positive because it's actually obeying the laws of gravity. And the acceleration due to gravity is approximately 10 meters per second squared. 10 meters per second squared. In some books, they use 9.8 meters per second squared. But just for the sake of simplicity, we are making use of 10 meters per second squared. This is what happened to a body that is falling down. Now, these are the tips. These are the things that you need to remember. What then happens when a body is being thrown upward, right? That is, a body is thrown upward. Now, you will agree with me that this body is antagonizing the law of gravity. So as a result of that, it's going to be negative, or you're going to have minus 10 meters per second squared, right? Now, the U can be computed. In other words, can be determined or can be calculated. Now, the V automatically becomes 0. These are the tips that you need to remember in order for you to do well in questions that have to do with falling bodies. I'll repeat this. A body is falling down, U is equal to 0, V is equal to, can be calculated or determined, then G is 10 meters per second squared. And when the body is projected upward, V is 0, U, it can be computed, and G is minus 10. So these are the facts that you need to take on when we start our calculation in falling bodies. Hope to see you in the next class.